Hello everyone and welcome to my channel. In today's video, I'm going to show you guys how you can design a suspension knuckle or an upright. It will be a simple design, but still you can take references from it and adapt as per your requirement and designing needs. So without wasting much time, let us begin. I am creating the suspension knuckle on the double wishbone suspension geometry. So firstly, we will create a plane which will pass through the steering axis, or you can say caster angle axis. For that we need three references. First two will be the references which are upper ball joint and lower ball joint coordinates, and third reference will be the main right plane. It should be looking like this, like a line when viewed from side view, and a flat plane when viewed from front view. So click OK and our plane is ready. Now we will sketch on this plane. So select this plane and go to create sketch, and then press Ctrl+1 to switch to the front plane view, as we will create the sketch in this view. Now here we are creating the resting platform for mounting the upper ball joint and lower ball joint. Their bearing seat with washers will be fastened here. After creating these reference lines, make a line passing from the midway and later make a rectangle. We have to leave the space above for bearing seat of A-arm to sit on the top. Now give dimension to this sketch and we are done for upper ball joint, bearing seat, resting platform. Similarly, we will sketch for the lower ball joint, bearing seat platform. We are creating the platform below the lower ball joint suspension point, so that bearing seat of lower ball joint will sit above the lower resting platform. So here make the reference line of half length, and from the lower point of this line make a rectangular shaped platform of same dimension which we made like above. Now we will extrude these sketches along the direction of plane which we have created. Extrude them using mid-plane option, as we want to add the material on both sides. Extrude length will be 30 mm and press OK. So this is how initially the upper and lower platform will look like. Now we will create a plane on which we will sketch the main central body of suspension knuckle, which will hold the spindle. That plane needs to be at an offset equal to 25 mm from the back face of the lower resting platform. After doing that, press OK. Now we will do sketching for the main central body on this plane. So now let's create sketch on this plane. First create a circle for reference around which we will create a rectangular enclosure. Now make a double-sided line which will be perpendicular to the steering axis. Similarly, draw another double-sided line below the circle. Now give the relation and dimension to these lines. Coincide the midpoint on the steering axis. And similarly for the line below. After that, join the upper and lower lines. and then connect the upper line to circle with the help of reference line and give dimension to that line, that is the reference line. Similarly do for the line below. And after giving dimensions to all the line, we will extrude this sketch to a length of 25 mm. Towards outward, and our central body is done now. Now we will connect the resting platform of upper ball joint and lower ball joint to this central body with the help of lofted boss feature. Here we have to link the back face of upper ball joint resting platform to the top face of the main central body and align the guiding curve accurately. Similarly, we will do for the lower section as well. Our main body structure of the suspension knuckle is completed now. Now we will create the wheel spindle. For that, select this face and sketch on it. Select a circle and make its center coincident on the wheel axis. After that, define the circle by assigning a diameter of 25 mm and then extrude it up to the end point of the spindle. And then press OK. Now we need to create a bearing seat and shoulder on the spindle, which will hold the hub bearing and the hub itself. Firstly, we will create a shoulder which will act as a support and a stopper to the hub bearing. It should be enough in diameter to support the sidewall of the bearing. And keep the thickness of shoulder at 6 mm. After that, create the seat on which the inner race of the bearing will rotate. It should be thick enough to cover the thickness of bearing. I am assuming the thickness to be around 15 mm. And after that, press OK. Now we will create the design for steering arm. For that, first we need to create a reference plane with the help of suspension geometry coordinates. So create a reference plane. For that, select the steering pivot point and the wheel center point, and then select the main right plane. The reference plane will look like this, and after that, press OK. Now we will sketch on this plane from the top view. Firstly, draw two concurrent circles with the steering pivot point as the center. And dimension them according to the size of heim joint you are using. Heim joint is a tie rod end basically. Then extrude this sketch entity at an offset as the tie rod end will rest over this resting area. Now we have to connect this part to the main knuckle body. For that, sketch on the same plane and connect using any type of design. You can connect this part to the main knuckle body using any type of sketch or design. I am making like in this way. As it will counter the compressive and tensile forces when the vehicle is steered left or right. Please note that whenever I do multiple selection of sketch entities like line, circle, I press and hold left control key. So just keep in mind whenever you do the same. Make sure you make a closed sketch entity. After that, go for extruding. I am keeping it in the middle way of the thickness of circular extrude. To save some material and also support it in terms of strength. I am keeping its thickness less than circular extrude. After that, press OK and you are done with the steering arm design. Now we will create the design for brake caliper mount. Normally, there are various OEM companies brake calipers available in the market. So based on your calculation of braking system, brake disc and other braking calculations, you can select any brake calipers of the available two-wheelers. That being said, I am fast forwarding the video now to reduce the video time, as this design is totally dependent on the type of brake caliper you are using. I am designing this design based on assumption and some past experiences. So you are welcome to take reference from it and use it and adapt as per your design. Now we have to create holes for fastening the A-arms at upper ball joint and lower ball joint. For that we can directly go to hole wizard. Select the third option, which is normal hole, and keep the hole diameter of 10.5 mm for inserting 10 mm bolt. After that, position the hole on the steering axis. You can make the center of the circle coincident on the reference line which we made earlier for the resting platform of upper ball joint and lower ball joint. Now do the same process for the lower ball joint as well. And your suspension knuckle is ready. After this, you can apply material like steel or aluminum and you can measure the mass of it. Based on the mass, you can do weight reduction on your suspension knuckle as long as your FEA analysis gives you a good factor of safety. So that's all about the video for today. If you found the video informative, please hit the like button. In case you have doubts, you can ask them in comment section. And also please subscribe to my channel for more suspension and car videos. Thank you, and we will meet in the next video.